So I've had some requests to go through the actual Delta Math problems. Some people have been saying that they're having technical difficulties, so I kind of want to check that out. And then some of you just want more examples. So I'm going to go in, I've created a student account, and I'm going to kind of work through some of the problems, starting with the very first systems, and then going up until the most recent assignment. Okay, so here I am in Delta Math, signed in as a student. I don't do this very often for my upcoming assignments, but we are going to start way back at systems of equations. And I'm just going to go through one of each of these. So let's start with substitution level 1. And to kind of make this easier for you guys to see, I'm just going to screen over here so that I can show my work. So let's begin. On this problem, I see these two equations. They're both set equal to y, which means that they're equal to each other. So I'm going to go ahead and set them equal to each other. And I apologize that this doesn't look perfect here, but it's not great to type math on the computer. So, okay. So I want to get my x's to one side. So first thing I'm going to do is subtract that x from both sides. And then that gives me 0 on the left side. 5x minus x is 4x. Nothing's happened to that 32 yet, but I want to get my x by itself, so I'm going to subtract 32 from both sides. That leaves me with negative 32 equals 4x. Getting x by itself, it's being multiplied by 4, I want to unmultiply, in other words divide by 4. That gives me negative 8 equals x. So we have solved for x, that's only half of this question. It also wants us to solve for y, but that first equation, really nicely, x and y are the same thing, cool. So let's try the answer negative 8, submit, fabulous. Look how great we are. All right, let's try a level 2 substitution. Okay, so this is going to require a little bit more work. That first equation, I don't quite have y by itself, but I do have x by itself. So I'm going to substitute that amount for x in the second equation. So the second equation says negative 8x, but instead of x, I'm going to replace that with negative 3y. And then rewrite the rest of it. Okay, so everybody sees the substitution stuff there. And then simplifying, negative 8 times negative 3 is 24y plus 2y equals 26. 24 plus 2 gives me 26y equals 26, and that tells me that y equals 1. Okay, perfect. We know y. Now we can go back in using that first equation, substitute the value of y. Negative 3 times 1 is x, which means x is negative 3. Okay, so make sure to put your answer in the correct order, because even though we solve for y first, x should always come first in the ordered pair. So I'm putting negative 3, 1. Let's make sure we did it right. Fabulous. Number elimination is where we add or subtract one entire equation to the other. All right, so I immediately see that this 8x and negative add those equations. So I'm going to add one entire equation to the other. Negative 8x minus 2y equals 10. I'm just going to put a space in so that we can line it up a little bit better. Okay. So the x's cancel each other out. The y's, I have 1 positive, 2 negatives. That's going to leave me with negative y equals negative 13 and positive 10 leaves me with negative 3. And if negative y is negative 3, that means positive y is positive 3. All right, so we have one of the variables. Now we go back and find the other. Not going to be quite as straightforward as the last two examples. So I'm going to take that top equation and then I'm just going to substitute 3 for y and then just solve for x. So start by canceling out that plus 3 with a minus 3 on both sides. Okay, and that leaves me with 8x equals negative 13 and negative 3 makes negative 16. And then if I divide both sides by 8, it's going to give me x by itself on the left. Negative 16 divided by 8 is negative 2. If I have an x and a y, if I put those together into an ordered pair, it would be negative 2, comma 3. So that's what I'm going to put here into delta math. This is elimination level 2. I see that none of my only match up to where, like, if I just add equations together, they would automatically eliminate. So I'm going to have to do some kind of multiplication. I am going to select these y's here because I can take the second equation, multiply it by 2, and that'll give me the 6y to match the first equation. So I'm going to go ahead and take that entire second equation, multiplying both sides by 2. 9 times 2 is 18, 2 times 2 is 4, and 16 times 2 is 32. Okay. Oh, I'm sorry. I'm trying to multiply by 3. What am I doing? Okay, multiplying by 3. 3 times 9 is 27. There we go. And 48, I believe. So the reason I wanted to do that is because I matched that 6y. So I'm going to come in and write that first equation, 6y. Now we have 6y in both of them. So if I go in and subtract everything inside of this equation, then what happens is my y's cancel each other out. So there's the 6y, 6y, x those. 27x minus 6x gives me 21x equals, again, make sure the whole thing is being subtracted. Don't lose track of that minus sign. 48 minus 6 would be 42. And 42 is 21 times 2, which means x is 2. All right, we got x. We just go back in to find y. Substituting 2 in place of x, so 6 times x plus 6 times y equals 6. That's 12 plus 6y equals 6, and then I want to get rid of that 12, so I'm going to subtract it from both sides. All right, that leaves me with y equals 6 minus 12 is negative 6. I'm going to put the line there so that you guys can see kind of what happens there. Okay, and then I'm just going to go in and divide both sides by 6. And 6 divided by 6 is 1. 1 times y is y. Negative 6 divided by 6 is negative 1. So we have x is 2, y is negative 1. Let's put that into delta math. So there is like a harder elimination example where we had to multiply first. Elimination strategy. So we're trying to decide what we want to do here. I see that there are 5x and 5x, which if I subtract those two equations from each other, then those are going to cancel out. So I'm going to say subtract to eliminate x. All right, these ones should go pretty quickly because this is just the first step of what we did last time. So I think once you guys have gotten through those problems, these strategy ones should be fairly easy. So here, again, the negative 2y's are going to cancel each other out if you subtract them. So we're going to subtract to eliminate y. Now that just might be a tiny bit confusing because of the negatives, but just remember that if two things are equal, to cancel them out, you'd have to subtract them. That makes sense. If you added them, you would just have more negatives. All right, so determine the number of solutions was what came next. So for this, I'm going to go ahead and attempt to solve. I see the negative 2x and 2x, and so if I add, oops, that should be a plus sign. So I know that if I add these two things together, then those are going to cancel. So let's go ahead and do that. Just cancel each other out, make 0. Y plus y is 2y, and then 4 plus negative 6, you have 2 more negatives than you do positives, so that would be negative 2. Alright, so that I have 2y, if I divide both sides by 2, that gives me y equals negative 1. So there's definitely one solution. I can go back in, let's use that first one, 2x plus -1 equals 4. Solving for x, add 1 to both sides, gives me 2x equals 5. Divide both sides by 2, x is 5/2. So there's definitely a solution. So I'm going to select one solution. And okay, let's look at the 3x and -3x are going to cancel each other out. So I'm just going to add these equations together. And again, my goal there, I've got the x's canceling each other out. Ooh, also, the y's cancel each other out because I have positive y and negative y, and -1 and +1 cancel each other out. So you come to an equation that says 0 equals 0. This is always true. Like, 0 is never going to not equal 0. So because of that, no matter what value of x or y I stick in, it's always going to be true. So this is infinitely many true solutions. All right, that was a good problem. This guy is going to be a little bit more involved. I have 4, which is a factor of that 16. Okay, so what I want to do is multiply that entire first equation by 4. Okay, and I'm doing that because I want to eliminate that -16. So it gives me positive 16 plus 4 times 3y is 12y. 4 times 5 is 20. All right, so here's those two equations now. I'm going to add them together, and you'll see my x's cancel or eliminate. -14, positive 12 gives me -2y. 20 minus 18 is 2, and that tells me y is -1. It gives us the whole numbers, so we know we're doing it correctly, which is not always going to be the case in real life, but okay, so I'm going to take that -1, substitute it back into the first equation. 4x minus 3 equals 5. 4x, I'm adding 3 to both sides. Gives me 4x equals 8. X equals, dividing both sides by 4. 8 divided by 4 is 2. Okay, so we have an actual solution, only one of them, not infinite. We haven't come to anything weird, so I'm going to hit one solution again. Okay, another question about how many solutions. So we're going to go ahead. I don't have anything that immediately cancels. So I'm going to multiply the top equation by 2. It gives me 2x plus 2y equals -4 times 2 is -8. Okay, so now focusing on those two, when I add them, the x terms cancel, the y terms cancel. -8 plus 6 is -2. So I come to an equation saying 0 equals -2. 0 is never equals -2 or any negative number. So this is never true, which means there are no solutions. And hopefully Delta Math agrees. There we go. Right, that has been the Delta Math problems for solving systems of equations algebraically. Hopefully that was helpful for you to watch me go through some of those problems and do them step by step. I'm going to do the same thing with matrices, but this video is getting too long, so watch for the matrix video coming soon.